Right. Good morning, everyone. Welcome to today's class. Today is the last lecture about data visualization in Python, and we will talk about more graphing details. So the first topic is multiple subplots. We actually have seen a few examples about creating subplots in one figure. Okay. So now let's zoom in and talk about more details of creating subplots. So subplots are kind of a smaller plots in one figure so that you can see multiple plots at the same time. Usually it is for comparison purpose. Matplotlib has the concept of this subplots, okay, which are groups of smaller axes or plots. Okay. And these subplots might be insets, which means you have a bigger plot, and within it there is a smaller one. So this is called an inset. Or grid of plots. Okay. Grid of plots are kind of like subplot matrices in this way. Okay, so all of the plots have the same dimension, okay, or size, or other complicated layouts. So in this section, we'll talk about 4 routines for creating subplots in matplotlib. So first, we load libraries and set the graphing options, okay, style and inline. And then let's move on to the first routine, subplots by hand. So this is the most basic method of creating an axis. So in this way, we will use this function, the axis function, to specifically create a subplot each time. So this axis create a standard axis object that fills the entire figure. So by default, it will fill the entire figure. Okay. And optionally, you can add some arguments to describe a particular axis. So the argument is a set of 4 values: left, bottom, width, and height. So all of them ranges from 0 to 1. Okay. So basically, it will consider this is 0 and this is 1. Okay. 0, 0, 1, 1 somehow. Okay. So we first create an axis that occupies the entire figure, so the bigger one, using the axis function. And then we create a smaller inset here with 4 values, 0.65, 0.65, 0.2, and 0.2. So this 0.65 means the figure will start at 65% of the width. So which means this is 65% of the width, right? Totally is 1. The total width is 1. And the second figure, the second number, 0.65 means the same thing. So the inset will start from 65% of the height. And then 0.2 and 0.2. This means the width is 20% of the width of the entire figure, and the height is the height of the entire figure, 20% of the height of the entire figure. So you see, so this is about 20%, and this is about 20%. So you see, this is a very flexible way to insert a very small window in a bigger plot, a bigger figure. It's very flexible. You can specify the starting position and also the width and height of the specific figure, smaller axis. So it's a very flexible way. And the equivalent of this command with object-oriented interface is the axis function. So the previous one is the MATLAB matplotlib way, MATLAB style. So now we're talking about the second style, object-oriented. So we will first create a figure specifically, and then we will use the add axis method to add a new axis to the figure. Right? So the first axis is called AX1, right? And we follow the same strategy, left, bottom, width and height of the figure, specify the region of the smaller the subplot, right? So this is the top one. Yeah, this is a top figure, right? Left 10%, and weight starting from 50%, right? Here, starting from 50%, right? And the width is 80%, height is 40%. So basically, the first part will create the subplot on the top. Right? And similarly, we can create the subplot at the bottom using a similar syntax. Right? Except for the top axis, we omitted the tick mark labels using this x tick mark labels equals an empty list. And then after we created these two axes, these two smaller axes, we can create a plot for each of them using the plot function. So this is the first routine. Secondly, we can create a single subplot within the grid. So each time we call this method, it will create a small subplot, but it is assumed to be within a grid or matrix. Three basic arguments, number of rows, number of columns, and also the index of the plot to be created in this scheme. Let's take a look at this example. We have seen this before, actually. So this function assumes that the subplot is within a matrix or a grid. So you need to specify how many rows and how many columns in the matrix, and also specifically the subplot index of the specific subplot. So we actually have seen this before. We use a for loop to create a subplot one after the other, 1, 2, 3, 4, 5, 6. And also we at the same time in each iteration we print some text in it. Basically this tuple, row, column, and index. And so this is a subplot function. So each time we only create one small plot. And apparently this is not very convenient, especially when we have a very big matrix to create, very big grid to create. Oh, by the way, so this is an object-oriented way to create a subplot using this function. So the function is called add subplot if we use the object-oriented style. Very similar strategy. Just now we create a figure specifically first, and then gradually add a subplot to the figure, So in each iteration, we add a subplot, one subplot into the figure. And basically same strategy, but using different interface. And the third routine is to create a whole grid at the same time. In this case, we use the subplots function. Notice that there is an S here. So this means we'll create all of the subplots at once and then gradually fill each subplot. So, and we also have some optional arguments like char X, char Y, which allow us to omit some axes labels and also let the subplots share X labels or Y labels. Let's see. So in this example, we create a matrix, a subplot matrix with 6 windows, 6 panels at the same time. 2 by 3, 2 rows, 3 columns. And we also specify char x equals column and char y equals row. So this means we let all of the plot in one row to share the y-axis. I see. So for example, these 3 panels are on the same row. They will share the same y-axis, right? Y-axis and its tick marks and labels, so that we don't need to have axes over here and here to save space. Similarly, char x equals column means all of the panels on the same column, for example, this one and this one, will share the same x-axis. And this one is omitted. Okay? All right. So this is a subplots function. You can create a grid at once with all of the subplots. And gradually you can fill each subplot. Essentially, you can still use a for loop to fill the subplots. So there is one advantage of using this method. That is the subplots we created here, the axes, are NumPy arrays. So if you create a grid in this way, it's a 2-dimensional NumPy array. So you can actually use this brackets way to identify each axis, right? I, J. So this is a NumPy array. You can index specific axes. All right, the last one is more complicated arrangement. So this one is more flexible. You don't have to have same size subplots in the figure. You can specify different sizes for different figures. So we use this grid spec function. Right? So this one actually will not create subplots directly or the grids directly. It will simply create an interface, and that is recognized by the subplot command. So let's take a look. So in the following example, it creates a grid of 2 rows and 3 columns. So it will create a grid like this. Okay, and so let's take a look at this example. So the grid has been created, and then you can use the subplot function to specify the area or the number of panels that the subplot will occupy. For example, the first subplot will occupy the 0, grid, which is this one. And then immediately we print this text 0 here. Okay. And the second subplot will occupy 2 panels. Right? First row, right? Row index is 0, and column index is 1 column, which is from the second column to the last column. So basically, the second subplot will occupy 2 panels. Okay. And then we draw a sine curve in this subplot, etc. So see, it is very flexible. You can specify the which grade or grades or subpanels each subplot will occupy. So that it's kind of more flexible. And we can also use this function to create a plot, something like this, to show the relationship between 2 numeric variables and the individual distributions of each variable. We actually can do this using seaborn functions, right? last time we talked about it. So those functions are more convenient. But I believe those functions were inspired by this kind of um, operation. Right? So basically, for example, in this example, we create a grade with 4 rows and 4 columns. Okay. It's a 4 by 4 matrix. And we choose to use this area as the main area and main plot, which will show the scatter plot. And this area is for the histogram of y, and this area for histogram of x. Okay, so this is a very flexible way to create plots and subplots. All right. Next topic is customizing ticks. We rarely need to do so because usually matplotlib's default tick locations and formatters are quite reasonable. You don't have to specify them. But just in case you do want to adjust them, let's see how to do it. So first, hiding ticks and labels. Sometimes you don't want to show tick marks and their labels. You can do this. For example, we create a line plot for 50 random numbers, random numbers. And then we can specifically suppress the major locator, so see null locator for the y-axis and null formatter for the x-axis. So null locator will completely remove the tick marks and their labels. Okay? Everything will be removed. And if you only null formatter, it will remove the labels, but not the tick marks. However, in this case, it turns out that this null formatter also removed the tick marks. I think it's just because for this type of plot, no tick marks will be shown by default. I tried to get rid of this line and recreate a plot. So for example, let's see. So see if I get rid of this, the line, you see, oh, there is tick marks. I don't know. Then this formatter thing. Oh yeah. Oh, I know. It's for the classic style, for the very, very, I think in a classic style, the tick marks will be shown, right? Even if we suppress the labels. But I guess at the beginning, we use the default style, plotting style. Then the tick marks are suppressed automatically. So now we can see the results if we use the classic style. Anyway, so it will be useful to in this kind of class when you print out some images of faces. So definitely tick marks and labels are not useful, not necessary. So you can suppress all of them using this function. All right. And sometimes when you create subplots, you might have too few number of tick marks or too many, right? Too crowded. So you can adjust it. For example, we create this subplots matrix with 3 rows and 3 columns, right? And automatically it only add one locator, okay, in the range of in each panel. Only added one locator, okay, one tick mark. If you think it's too you need more, you can do this. Specify a max n locator to be 4. Then it will try to figure out a way to put the optimal number of tick marks in your plot. So for example, in this case, although the max end locator is 4, you see there are only 3 in the middle, right? 0.25, 0.2, 0.5, 0.75, right? And you can change it to 5. You can try it. You get the same. You get 4 locators in between 0 and 1. Right? So it's a way to adjust the number of tick marks in your subplots. Right? And then let's see. Okay. Fancy tick formats. We rarely need to adjust the tick formats. So this example shows you one example that you probably must adjust it. So in this figure, we have a sine curve and a cosine curve, right? And by default, integers will be used to label the x-axis, which doesn't make sense that much, right? Because ideally, we should use multiples of half pi to mark the x labels, right? Like pi over 2, pi, 3 pi over 2, 2 pi, etc. That will make more sense, right? So this part shows you how to adjust it, right? Eventually, if you really want to show the x tick mark labels in the correct way, you have to write a function to change the format, right, by yourself. Right? So because we rarely need to deal with it, I will skip this part. If you are interested in, you can zoom in and study this code, right, how to create the format function. So then let's move on to customizing matplotlib configurations and style sheets. Matplotlib's default plot settings are often of complaints because they are not really good looking, very raw. Fortunately, we actually can change these settings using the runtime configuration parameter options. So let's see how to adjust these parameters by hand. And also we can save the options for future use. Let's take a look. So this is a classic. So if we use a classic style, it looks like this. If we create a scatter plot, it looks pretty bad, bad looking. And if we want to adjust it, definitely we can, for example, make some adjustment, like the color of the grid, and face color of the bars, etc. A lot of things. Okay? And then eventually we can create a histogram like this. Okay? If you are familiar with ggplot2, you can tell that this is inspired by the ggplot2 style. Right? By default, the bars will be in orange color with a gray background with white grids. Okay. Of course, it requires a lot of effort. Right? To avoid this, we can actually save the settings by ourselves, right? And then use it after we call the setting or we change the setting. Okay? So to change it, we need to change the runtime configuration parameter, the RC parameter. So to keep the default option, we first save it. We use rc_primes.copy to save the current setting and save it in this object, IPython default. Okay. And then we can change the runtime configuration options. Right? So we first import a function from matplotlib and create a bunch of colors. Right? color codes. So these will be the default color codes for my new setting, right? For my new plot settings. So namely, if I don't specify what color I want to use, then the first color will be used as the default color for the histogram. Right? And then if I have multiple groups of data, and then it will cycle these 6 colors. Right? And then some other options. So after we run this, then by the way, you need to change runtime configuration of parameters using this function, RC function. You can change axes, rate, x-tick, y-tick, patch lines, etc. Right? So after we do this, then currently my runtime configuration parameters will be like that. And then after we set everything, we can, if I create a histogram without specifying any additional arguments, I have a histogram like this, right? So this is similar to the ggplot2 setting. And if we create a line plot with four lines, then we'll see a plot like this. Right? So see, I didn't specify the colors I want, but it will just cycle the colors in the list, right? 1, 2, 3, 4, 4 of them. Okay. And the settings can be saved in a matplotlib RC file. And you can read about this in matplotlib documentation. You can actually save your own preferred style. All right. And matplotlib actually has released some style sheets. We actually have used some of them so far. We have seen classic and seaborn white, widespread already, right? I've seen all of these already. So notice that there is ggplot style sheet. So now let's explore some of them. When you want to use a style sheet, you use this kind of syntax, pyplot style.use. We actually have used this before. Right? And if you only want to use the style sheet on a specific plot, then call this a with function, with and the setting and column, then the syntax you use to create the code you use to create a specific plot. So now before we start, we will create a function so that 2 plots will be created automatically whenever we call this function. So see, the function is called hist and lines. It will create a histogram and a line plot at the same time. So now let's first go back and use the default runtime configuration. Remember, we save everything here, IPython default, and now we can use it. I update the runtime parameter to change it back. So this is the default loop, the classic loop, the default loop of the IPython notebook. And then let's use the 538 style. And the plot looks like this. So 538 is a website or website for which contains some data science and visualization projects. And so this is one style, and then ggplot2 style. It's just called ggplot. Okay. And this is the Bayesian method for hacker style, which looks quite neat too. And this is the dark background style. Next one is grayscale, very cool. And then seaborn, we're familiar with this, right? I'll use this. And this seaborn colorblind. the color palettes will be slightly different. All right, perfect. That's all for today. And don't forget